Hi, my name is Lee Tao, and I am a business development manager at Gore and Associates. I'd like to discuss new 5G wireless technology, the challenges of 5G component level testing, and how we can help to alleviate some of these challenges by introducing you to our product portfolio. In today's agenda, we are going to discuss 5G wireless technology and testing challenges, requirements for microwave and RF cable assemblies, key factors impacting cable assemblies reliability, and the Gore microwave and RF cable assembly solutions. Let's start by talking about 5G wireless technology. Current LTE and LTE advanced communication architectures cannot accommodate today's market demand for higher data throughput, greater cell capacity, and more reliability. As a result, new 5G cellular standards are being developed to achieve the desired performance goals, operating within the frequency range of 24 to 100 GHz. The challenges to microwave and RF cable assemblies in 5G test systems are similar to other test systems. However, 5G testing has the added twist of over-the-air testing requirement. So, 5G component level testing challenges include high-frequency component level testing above 6 GHz using multi-port testers, frequent calibration on test systems, achieving highly accurate test results, demands for faster development with reduced overall costs. Therefore, the 5G test industry requires improved reliability on microwave and RF cable assemblies to help improving test outcomes. In the end, you cannot trust the product performance if you cannot trust the test results. Looking at massive MIMO OTA testing, there are several challenges that include test accuracy and repeatability, repeat testing due to recalibration, and extending the product design cycle. When connecting microwave and RF test cable assemblies to massive MIMO OTA test systems, consider if an assembly can deliver consistent operating characteristics during handling and use over time, endure initial routing into chamber and subsequent movements during testing, ensure high accuracy and preserve antenna efficiency with low loss and visual, deliver high degree of stability pertaining to phase and amplitude with movements, offer excellent shielding effectiveness to minimize EMI that would negatively influence test results. To calibrate a 4-port VNA using a mechanical calibration kit, it takes about 4 to 5 minutes to complete the calibration process. To calibrate an 8-port VNA, it takes about 8 to 10 minutes. To calibrate a 32-port VNA, it takes about 30 to 60 minutes. If one cable assembly fails, then you need to recalibrate the entire system multiple times to locate that failed cable assembly. The associated cost would be huge. Now, let's talk about the requirements for microwave and RF cable assemblies and the key factors impacting their performance and reliability. The reliability of microwave and RF test cable assemblies is based on electrical performance, durability, and stability. Microwave and RF cable assemblies should have the following attributes to accurately and effectively support component and system testing. Selecting reliable microwave and RF cable assemblies will eliminate the common problems experienced with test systems, such as increased troubleshooting and maintenance. frequent recalibration, additional retesting, delayed production schedules, increased total cost of ownership, and compromised system performance. Let's start by looking at the key factors impacting electrical performance of microwave and RF cable assemblies. First, most microwave and RF cable assemblies perform well when new or right out of the box. However, problems start when these inferior cable assemblies are subjected to the rigors of daily use in a test system. Second, repeated connect and disconnect cycles can prematurely wear a poorly engineered connector interface, causing visual insertion loss and measurement repeatability issues. Third, cable assemblies that are not adequately ruggedized for a test environment will quickly become damaged, compromising insertion loss and visual performance. Consequently, over a very short time, an inferior cable assembly will become a test system's liability. Next, let's look at the key factors impacting the durability of microwave and RF cable assemblies. Mechanical stress occurs when cable assemblies are exposed to various types of movements, and one of the biggest causes of mechanical stress on cable assemblies is when they are frequently handled. An operator can kink, pinch, or crush a non-ruggedized or poorly protected cable assembly by stepping on it or rolling an office chair over it. Also, cable assemblies used with portable equipment can come into contact with sharp surfaces that could cut the cable assemblies or expose them to abrasion. So, crush resistance and tensile strength are essential in overcoming mechanical stress. Now, let's look at the key factors impacting the stability of microwave and RF cable assemblies. It's a common misconception that all cable assemblies are stable. There is stability in phase and amplitude with movement. Without it, the user cannot move or flex the cable assembly after system calibration. There is stability in phase and amplitude with temperature. Without it, system performance is unpredictable. I'd like to take this opportunity to show you how Gore can help to alleviate the challenges by introducing you to Gore microwave and RF cable assembly solutions for 5G testing. With more than 40 years of design expertise, we manufacture microwave and RF cable assemblies that provide enhanced durability while delivering proven phase and amplitude stability with flexure and over temperature. We offer a broad portfolio of cable assemblies for test and measurement, spaceflight, aerospace, and defense applications. Our portfolio includes cable diameters ranging from 0.047 to 0.42 inches at frequencies from DC to 110 GHz in low-loss cable constructions. We also design and manufacture a selection of robust connector options designed to optimize the performance of our cable assemblies. And unlike other suppliers, we manufacture our own dielectric materials and precision flat wire outer conductors for microwave and RF cable assemblies. We ensure consistent performance and quality control of our products throughout the entire manufacturing process, from raw materials to the finished product. With our proven track record and reputation, we are proud that our cable assemblies are the preferred solution for test systems by key global OEMs. Known as the purple cable in many industries, Gore PhaseFlex microwave and RF test assemblies are our most popular product for test applications. They are proven to deliver excellent phase and loss stability with flexure for test applications that require precise, repeatable measurements up to 110 GHz. Our cable assemblies have a unique, internally ruggedized construction that protects against crushing, kinking, and fluid ingress, while also being highly flexible and easy to handle. The newest version, Type 0N, is designed specifically for multi-port test equipment. Their long service life enable longer test system uptime between calibrations for greater measurement accuracy, repeatability, and throughput, which makes them the ideal solution for 5G communication test systems. The picture shows internal construction of our PhaseFlex cable, and we are proud of being a recipient of Gold Honoree of Military and Aerospace Electronics Innovators Awards in 2020. We test the stability of Gore PhaseFlex microwave and RF test assemblies through 70 GHz in 4 steps outlined in this slide to ensure the assembly is flexed in 2 planes. Then we choose the worst case test results to generate the test report. This graph demonstrated the phase stability with flexure performance between Gore PhaseFlex microwave and RF test assemblies and the 2 alternative test assemblies. Here you can see the alternative assemblies experienced a significant change after several hundred cycles. In contrast, Gore's assemblies experienced no change in performance after 10,000 cycles. Looking at this graph, we see the performance comparison for lost stability with flexure. Again, the alternative test assemblies experienced a significant change after several hundred cycles, while Gore test assemblies experienced no change in performance after 10,000 cycles. Now let's look at our solutions for general purpose testing and high density interconnect applications. For general purpose test applications that require consistent and highly repeatable measurements, our test assemblies provide reliable electrical performance with proven phase and amplitude stability from DC to 70 GHz. They deliver mechanical and electrical integrity in lightweight, durable construction with smaller diameters and high flexibility, which means they simplify the routing process while ensuring long-lasting electrical performance after installation, particularly in board-to-board and inside-the-box applications. Our test assemblies deliver maximum flexibility and reliable, repeatable electrical performance, unlike traditional flexible alternatives. Constant and highly repetitive movement of cables can compromise the measurement precision of high-performance VNAs. We set the industry standard with Gore VNA microwave and RF test assemblies for vector network analyzers through 70 GHz. They are proven to consistently deliver high accuracy results and the outstanding phase and amplitude stability with flexure. Our test assemblies are specifically engineered to provide the most precise VNA measurements under lab conditions. They have a rugged, lightweight constructions that enable longer service life, reduce downtime, and lower the total cost of ownership over the life of the test equipment. In fact, the world's leading VNA manufacturers choose us because they know our test assemblies allow their products to achieve peak performance. We offer a broad portfolio of durable microwave and RF test assemblies, including VNA microwave and RF test assemblies for metrology and high-end R&D that set the industry standard up to 70 GHz. PhaseFlex microwave and RF test assemblies for R&D and manufacturing that are internally ruggedized at a frequency up to 110 GHz. And our microwave and RF assemblies for general purpose test and high density interconnect applications from DC to 70 GHz. Visit our website to find out more detailed information about our microwave and RF cable assemblies. Follow us on social media to stay up to date on the latest information and events. And try our online tools to configure and request a quote for a cable assembly with a variety of connector, cable, assembly length, and frequency options. Thank you.